Hey guys, welcome to SI 2.5a. We're going to be talking about in this video, how do I decide whether or not to create a line graph or a bar graph based on the data that I collect. There's very certain differences. There's very specific differences between those two, and so we're going to talk about those in our lesson today. First, I want to talk about, well, some characteristics of each graph, and this is in your notes. Our line graphs, they always show change over time. We saw that in lesson 2.4. We were talking about in the lollipop lab, the changes of licks continually per minute. Where bar graphs, they often just show or compare data. Okay, and so I'm probably just comparing, different sales, different groups, different votes. They're just separate groups of data that we're comparing the quantities of. And so a bar graph just shows and compares data, whereas a line graph shows change over time. Another difference is how the data is kind of represented as well, not just because of lines, but line graphs show trends and how that data changes. It's continuous. It gradually changes. That's why we use a line graph. Whereas with bar graphs, the data is separated into different bars and it's disjointed. And there wouldn't be any purpose to have lines in the middle because they're completely separate. And if I put them together with those lines, it would make a relationship as if they were connected, or if there was a gradual change from soccer to football votes, and that's just not the case. And so those are some characteristics of each graph and the data that should be shown in those. But the big difference is this: line graphs show change over time. Okay, and you should know this. This is the big litmus test there. Whereas bar graphs, they'll often show just comparisons of data and groups. And so you want to make sure that's in your notes. And so we're going to look at an example in general. There was a dance last year, they called it the dark dance. And with the dark dance, you would have glow sticks that were on sale, and you wore glow-in-the-dark stuff. But here's the attendance that we've had for each of the couple years. So I want you to ask yourself for a moment, based on what we talked about here and here, what do you think I should make for this graph? I look here, I see years, and I see students attended. I'm thinking years is a time label, just like minutes, seconds, hours, days. And so with this, I'm seeing a change per year, so a change over time. So I'm thinking this should be a line graph, and you would be correct if you did that. And so here's an example of the line graph of the change over time, and I see how the data increases from 2005 or 2006 to 2009. And so I could use that trend to make a prediction for 2010. You see how it's continual for each year. Now let's take a look at this graph here. Dark dance tickets sold per group. I have here student council, cheerleaders, newspaper club, and band. And I have their data here. What is my data comparing? Am I comparing minutes and how many tickets we got per minute? I'm comparing groups. These are going to be disjointed. The people that are in student council aren't selling tickets with cheerleaders. They're completely different. They're competing for who can sell the most tickets. So as a result, we're going to be talking about a bar graph. And so here's our data there. You can take a look at that for yourself. We'll make it a little bit bigger for you. Okay, and so let's go over the examples that are in your notes. Funnel cake sales for the New Holland Parade by restaurant. We have all these different ones here. I want you to think, what am I comparing? Am I doing change over time, or am I just comparing groups? Okay, this would be a bar graph, so we're going to call it a bar graph. And for my rationale, why is it a bar graph? Well, if I look here, I see that there is groups, and there's no change over time. I just see I am simply comparing the sales of groups. Here's your other example here. I have the height in centimeters of plant grows. A plant grows over 3 weeks. And so we got week 1, week 2, week 3. And we see a change, and a week is a time label. And so as a result, this would be a line graph. Okay, and why is it a line graph? Our rationale is this. Since we use weeks for the data, this graph shows change over time. This graph shows change over time. And so here you have it. Remember the big differences between them. If I jump back here, is that we have change over time for line graphs, and then bar graphs just compare data. And so with that, I'd like you to take a look at your activities for today, and then you're going to use that to tell me about your lab that you conducted on boiling water. And I want you to think, am I going to be using a bar graph or a line graph? So with that, you guys can get to work.